Hi everyone, just wanted to take a minute to talk a little bit about similarity. So similarity is going to relate really closely to what we were talking about in regards to proportions, and we're going to be able to use what we were learning about with proportions to solve some problems in relation to similar figures. So anyway, our goal of the day is to really determine what it means for two shapes to be similar, and then figure out when they are similar. And then we're also going to use the properties of similarity to solve for missing parts of polygons. The main polygons that we typically look at in terms of similarity are triangles, but we can apply these concepts largely to all polygons. So to start off, what exactly is similarity? So similar polygons are going to be polygons that have the same shape, but not the same size, right? So congruent, right? When they're congruent, they're the same shape and size. You know, if this side's 2, this side's 2. When that side's 4, that side's 4. They would have the same angles and everything like that. In a similar polygon, which you're going to indicate with this symbol, right, the little squiggle here, in a similar polygon, the sides are going to be proportional, okay? The angles will still be congruent, okay? So the angles will still be the same, but the sides are going to be proportional. So what does that mean? That means if I were to set up a proportion between I, J, and CD, right? It would be the same proportion as if I did GJ and this one, which is related to it, right? AD. So this number would be the same. If it was 1, it's getting bigger. So let's say it was 2. This proportion would be 2. This would be like 4, and this would be 2, or something like that. And this might be, I don't know, 4, and this might be 8, right? So times 2, times 2. So that is what we're going to be ultimately dealing with. Now, how do we actually figure out if something is going to be similar? Well, we have to look at something called the similarity ratio, which is going to be the ratio between corresponding sides of similar shapes. So what do I mean by corresponding sides? I mean, see how this one, is going from the bottom up. This one's going from the bottom up, right? These ones would be corresponding. They're in the same kind of general location. So this goes from 2 to 4. This goes from 4 to 8. This goes from 6 to 12. Now, we have to make sure that we pay attention to which way things are going. Because if they're going from the smaller to the big one, it's going to be different than if we go from the large one to the small one, okay? So the order matters, right? So when we're dealing with this larger shape in the numerator, we're going to have a ratio of 2, right? The ratio from here to here is 2. But the ratio from here to here is 1/2, okay? So you have to be careful with which direction you're going. I'm always going to be, specific in telling you which way you're going, but you need to make sure that you're careful, all right? All right, so how would we actually figure out the similarity ratio? So we're going from here to here. So this is our image and this is our pre-image. So what I'm saying from left to right, I'm saying this is our pre, and then this is going to be our image. Oops, image. Okay, so because this is the image, this is the one that's going to go in the numerator. So I'm going to say 16 is in the numerator, and the corresponding side to the 16 here is this 24 over 24. Okay, so when we simplify that, that's going to ultimately simplify to what? Well, what does this have? If we take out an 8, and we take out an 8 here, that'd be 2 over 3, right? And let's just confirm that by looking at another one. So if we're putting the 10 here, again, it's still 2 over 3. So if you always want to check yourself, make sure to look at another one. And if it's the same ratio, then you're good. So the similarity ratio here would be 2 over 3, or 2/3. Okay. What about this one? So to find the similarity ratio, we need to make sure that we have these kind of in the same orientation. Now, obviously, this is like kind of flipped upside down. So really, it would look kind of something like this. 7, 8. Okay, so the 7 would correspond to the 14, the 12 would correspond to this side, which we don't know, and this side corresponds to the 8. So we have to do 7 to 14, right? Because the one on the right, the end, the image, is what goes in the numerator. So it would be 1/2. All right. So you just, again, you need to be careful with your ordering and determining which thing is going to be the image. Because if you put the wrong one on top, it's going to come out as the opposite. Okay. So where do we go from here? Well, that's great, but we can actually also set these up so that we can solve for sides, all right? So if we know the 15 is corresponding to the 5, and the 18 is corresponding to the x minus 2, we can set these up in a proportion because we know they're going to be in the same ratio, okay? So the 15 over 5 has to be equal to whatever 18 over x minus 2 is. And then from here, it's going to be the same process of solving with proportions that we were working on in the past, right? You're going to cross multiply. Don't forget to distribute the 15 to both the x and the negative 2. And then you would simplify to solve for x. All right? So in these ones, if we solve for the variables, what would we do? Well, we have to make sure we set it up correctly. So the 24 is corresponding to the 16. So 24 is to 16. And that should be equal to the 21 to the x. Now, what are we going to do with this? Well, again, we're going to cross multiply. So let me cross multiply. So 16 times 21 has to be equal to 24 times x. Now, 16 times 21 is going to be 336. That's equal to 24x. When I divide both sides by 24, I get that x is equal to 14. Okay. Now, on this one over here, we need to be a little bit more careful. And the reason we have to be a little bit more careful is they're not necessarily in the same orientation, right? So this 18 is corresponding to this 9. This 12 is corresponding to this 3y plus 3. And the 5x minus 2 is corresponding to the 21. So it doesn't do me any good to do both the x and the y at the same time. So I'll have to do them in separate goes. So I know that 18 is to 9, right? 18 is to 9. As 12 is to 3y plus 3. Again, I'm going to cross multiply. I'm going to move my head over here. All right, so I'm going to cross multiply. So I would get 18 times 3y plus 3. And that's equal to 9 times 12. Okay, so when we do some multiplication out, oops, wrong button, sorry. So 54y plus 54 is equal to 108. Sorry, I looked quickly at my calculator and I hit the wrong button. I always like to make sure I do my multiplication correct, so I'm usually checking it as I go. I don't have to redo it. So if I subtract the 50, that looks horrible. Let me just erase that. Let me rewrite that side. So that is 54y plus 54. Okay, I subtract the 54 from both sides. I get 54y equals 54. So y would equal 1. Okay, now I still need to solve for the x. So again, I still know it has to be 18 is to 9. But now instead of doing the 12 is to this, I'm going to do the 5x minus 2 is to 21. Now again, you need to be careful because if you don't put the right one on top, it's going to be incorrect. So if you're putting this one on top on the first side, you put this one on top on the second side. Okay? So 18 times 21 is 378, which is equal to 9 times 5, which is 45, minus 18, 45x. So I'm going to add the 18 to both sides. That is 396 equal to 45x. Okay, divide by the 45, which ultimately will simplify to 44 over 5, which is equal to 8.8. All right, so we ultimately get that it's equal to 8.8. So if we were to plug that in, that would create a triangle that is similar. Okay, so these are my various answers. Ultimately, we just need to be careful with setting it up, because if you don't set it up correctly, it won't work out right. All right, last thing. If we were to restrict it to triangles, there's a couple ways that we can determine that we have similar triangles. All right. So a similar triangle, again, it's the same as any other similar polygon. The sides are in proportion, and the angles will determine, and the angles are congruent. So there's three ways for us to determine if a triangle is similar. The first is that if we have two angles being similar, two angles are congruent, then the triangles are similar, right? So if these two were congruent and these two were congruent, because they both add up to 180, right? We know that the remaining side would have the remaining angle would have to be congruent. So if I know that two sets of angles are congruent, I can say that these triangles are congruent. If I know that all three sides are in the same proportion or in the same ratio, that would make sense. That's just the definition of what it means to be similar, right? And then finally, if I have two sides and the angle in between, the two sides are proportional and the angle in between are congruent, then I can say that these triangles are similar. All right, so those are the three main methods that we can use for triangles. So if we look here, what can we figure out? Well, in order for us to figure out this first one, since we're given angles, is we do need to figure out if we have two sets of angles that are congruent, or I guess in this case, all three. So what do we know here? They all add up to 180. So 180 is equal to 80 plus 70 plus whatever this is, plus x, right? 180 is equal to 150 plus x. X is equal to 30. So that makes this one 30. So because this is 30 and this is 80 and this is 30 and this is 80, we know from AA, angle similarity, that these two triangles are similar. Yes, by A. Okay. Now let's look here. We have an angle here that is congruent to this angle, so that's good. So that sets us up for either angle or side angle side similarity. Now we only have one angle, so we have to then look at the sides. So what are we going to do? Let's look at this. So we have 12 is to 8, and then let's look at the other side. 15 is to 10. So 12 is to 8. That simplifies to what? 4. Oops, nope. Not 4. 3. 3 over 2, and this comes to 3 over 2. So they are in the same proportion, right? This is 3 over 2. This is 3 over 2. They have a congruent angle, so yes, by side angle side similarity. All right, last one. Are these triangles similar? Well, we don't have any angles, so we need to show that all three are in the same ratio. So let's make sure, first of all, we know what the heck is happening here. The 16 relates to the 12. It appears to me that the 8 is relating to the 9, and the 12 is relating to the 6. So let's figure this out. Is 8 relating to, oh no, I made a mistake, I'm sorry. 8 is to 6. I looked at it quickly. So 8 is to 6, as 12 is to 9, as 16 is to 12. All right, so if I simplify this, this is 4 over 3. If I simplify this, divided by 4, divided by 4. I'm sorry, divided by 2. That would be 4 over 3. If I divide each of these by 3, it's 4/3, right? So yes, by side, 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 similarity. All right, so those are the 3 methods you can use to show that things are similar. You do need to be careful, right? I made a mistake the first time I looked at it in regards to the 8 and where the 8, the 6, and the 9 went. So you do need to be careful. But ultimately, if you can show that all 3 are in the same proportion, then these will be similar. All right, if you have any questions, let me know, and have a great day.